Okay. Good morning, everyone. Sorry for that technical difficulty. I think that we should be all right now. Let me quickly introduce myself. I'm Jinan, and I work as a technical analyst at Emirates Green Building Council. If this is your first time joining us for our technical webinar, you should be seeing this toolbar on your right side. You are currently on mute, okay? And if you have any questions, you can click on the questions area and type in your questions. And at the end of the session, I will be relaying your questions to our facilitator. And after the presentation, we will be sharing the recording of the event. And a week or two from now, it will be on our YouTube channel. So if you don't follow us there, give us a follow and also check our accounts on our social media accounts, such as LinkedIn and Facebook. Our facilitator today is Dorian, and he is the head of specification at Saint-Gobain, UAE. He has 10 years of experience in construction and building material industries in France and here in the UAE. And he is also the person in charge of developing the product transparency strategy for Saint-Gobain Gyproc Middle East, which includes gypsum board recycling, LCA, EPD, and HPD. Okay, Mr. Dorian, I think that we've taken enough of your time, so please take the stage.
Thank you, Jinan. Good morning, everyone. It's a pleasure to be here and to try to give you a little bit of insight of today about sustainability and acoustic as well, and all the two topics together that can help reducing the embodied carbon on your project. So I can go ahead with the slides. I think yes. So let's start with the vision. Why should we, reduce the embodied carbon? The World Green Building Council is setting the guidelines, and in 2030, all the new buildings should be, zero operational carbon, and in 2050, it's all of the building, even the old one. So, of course, there is a huge amount of work to do for retrofitting, and today we will not talk about retrofit. It's an important topic, and I think there is great training from the EGBC about that. But today we will talk about the new buildings and how to reduce as much as possible the risk of the need of retrofitting if you can design the building in a better way. Why? It's because building construction market, it's 30% of the energy consumption, 40% raw material consumption, 40% of solid waste generation, and that's just for today, because the population will increase, and of course the resources requirement, the needs of resources will increase as well, and it might increase by 50% for the raw material, 40% for the water demand, and 40% for the energy demand. So we believe that using the traditional way of building might not be the only solution. I cannot pass the slide. And we're not the only one. I think perhaps Lewis Perkins is president of Cradle to Cradle Product Innovation Institute, and he believed that the world does not have a consumption problem, it has a design problem. And actually, you will see that through the design, you can select the right material and you can reduce raw material consumption on a project by improving well-being and improving sustainability. So this is the agenda for today. We will cover sustainability and acoustic comfort, or the two are linked together. Then we will quickly review the regulation in Dubai and UAE, what matters for acoustic. Then we will take one example of a traditional building material. You will see the impact once the product is installed on a project. You will see the impact for sustainability, the impact for acoustic, and I will show you modern systems, some modern systems that will improve the well-being for acoustic and that will reduce the environmental impact. And then we will quickly discuss about product transparency at the end of that presentation. So yeah, let's go. So just before, I will not introduce Saint-Gobain. It's a very big company, 250 years old, in more than 68 countries. I will just tell you what we're doing and in our innovation process, what we have in mind. Saint-Gobain today is trying to develop comfort and sustainability. So we will improve the performance of our system for the comfort of the end user, of course, but also of the installer and actually everyone involved on the project. And of course, we don't want to increase the challenges for the next generation. So we also consider sustainability in our product. The objective is that with our product, we enhance the well-being of people everywhere in our buildings. And we created one program called Multi-Comfort by Saint-Gobain. I think the World Green Building Council is also involved with that. And we are considering the multi-comfort. For us, it's what you can see, what you can feel, the air you breathe, and also the acoustic. And this is you need today when you want to buy a building, when you want to buy an apartment, when you want to live in your apartment, you want to feel good in that apartment. But then you have to consider all the challenges for the next generation. You don't want to damage the next generation. So you have to consider the water consumption, the biodiversity, the amount of energy you consume, the amount of material you consume, and if it's recyclable. And that's why we are creating some tools. And you will see in that presentation, I will talk about LCA, about EPD, because that's the best tool today to compare two products from the same family to see which one has a higher impact. So today we will focus on this part of acoustic comfort here. In acoustic, you have two big families. You have sound insulation and sound absorption. I will only cover the sound insulation. Why? Because I think one of my colleagues did the training about sound absorption a few months ago, and you will see that the biggest impact are for sound insulation. But quickly, I will define what is the difference between these two. So the sound insulation, it's like what we call room-to-room acoustic. You don't want to be disturbed by the people next door. You don't want to be disturbed by your neighbor. You don't want to be disturbed by the next office. So you need to achieve the right level of acoustic privacy, depending of what you're doing in the building. If it's a house, it will be different than an apartment. It will be different than a school, and of course, than an office. What you want to do is by creating a barrier between the two spaces, you want to reduce the sound transfer. You don't want to know what's happening next door. And the other one is the sound absorption. You want to control whatever is happening in the room. You want to improve the speech intelligibility. You want to understand 100% of the word coming from the speaker in the room. And you want to reduce the ambient noise around you. You don't want to have echo. You don't want to have reverberation. So like this, you feel comfortable. Everybody understands when you're in an airport or a train station, sometimes you have more echo. That's okay. In swimming pool, you have more echo. That's okay. It's a swimming pool. But then when it is your home, when it is a school, you want to control that. You need to be comfortable in that space. But again, today we will focus on sound insulation because these barriers are the one using the biggest amount of material. And once you select the system, you have to also to consider some parameters. So if you install a wall between two apartments, it has to be airtight. If you create a massive wall, but it's not airtight, if you have some small holes everywhere, of course, the sound will travel to that holes. You have to make sure that you're providing the right detail. If you have any penetration for HVAC or any pipe going through the wall, if you have some structural deflection, you have to make sure that it's not destroying the head of the partition. You don't want to damage the wall, because then it will be an issue for a lot of parameters and for acoustic. And you have to make sure that you're considering all the flanking details with a correct implementation. We will use one example in that presentation, which is the electrical sockets. Everyone has electrical sockets in your apartment, in your office. And you will see that depending of how you design the position of these sockets, you might damage the acoustic performance. And what if you don't have a good acoustic? So what if well-being is not achieved in different projects? For instance, World Green Building Council develop on the website, you can find a lot of information, better places for people on the World Green Building Council website. And you have a lot of information, like for instance, for school, you can see that if you have a noisy HVAC system, and then you have less achievement from the student. If you are more noise in the room, let's say 10 dB in France, the math scores are decreasing by 5.5 points, which is huge. In the UK, if the school is next to an airport, actually the people with misheard 1 in 4 words. So 25% of what you say is actually lost. And even in New York, there is a great example of the reading levels are going down if you're next to an airport. So of course the location of the building is important, but then if you cannot change the location of the building, you can work on acoustic to treat that. Especially in Dubai, where schools are so expensive, you don't want all of that for your child. So acoustic is very important. In offices, 66% of fall in staff performance is because of a distracting noise. Might be your neighbor, might be somebody walking in the floor upstairs or downstairs, and then the sound is going through the million of the glass, and then you cannot walk properly. This is real life experience. That was my previous office actually. So it's happening to everywhere. And if you want to be 100% at your best level, then you have to deal with a good acoustic. I took this picture from ACOM website. It's more related to healthcare sector, and this is showing where the disturbance are coming from. You can see that for the patient, they're disturbed by the noise coming from the nurse's station. So in that case, the walls between the patient room and the nurse's station is not well designed, so the sound is going through. You can have a transfer through the corridors, noisy coffee, they cannot sleep. And actually, once you consider all of that parameters, you can see that it has an impact on the blood pressure. It has an impact on the recovery time. It even has an impact on how much painkiller the patient are requiring. So by improving the acoustic, by achieving acoustic comfort in such building, you can improve the sleep night, reduce the blood pressure, reduce the amount of medication, and also improve the turnover, so people will come and they will recover quickly. So there is a huge impact. There is also similar studies with the blood level and the heartbeat for the teachers when they're working in a noisy environment. So, of course, hopefully, there is some regulation. And if you want to design a school or a hospital or even an apartment, you're not alone, and there is regulation, but people have to understand the regulation. And a regulation is a guidance, and you need, it's generical. And then depending of the project, depending of the situation of the building, where it is located, depending of the size of the room, depending of the material you're using of the room, depending of how many people are in the room, the parameter might be different. That's why it's not mandatory, but it should be mandatory to work with an acoustic consultant on those projects, because the regulation is never enough. And if I will show you the regulation, you will see that even if you read 100% of what is in the regulation, you might not master 100% of the acoustic requirement for your project. So again, the acoustic consultant is a must for a project. In Dubai, the building regulation, the Green Building Code, Al-Safat, if you look into it, there is not even a guidance for acoustic. There is no values, there is no numbers, there is nothing. There is only one small page, which is sending you to another regulation. And for instance, for residential building, you have to refer to the approved document E from the UK, something done in 2003. So is it the right level of acoustic? Perhaps not, because the noise level in cities increased a lot in the last few days. So again, the acousticians, you will be able to adapt those parameters for you for the project. Then there is other document for schools, it's BB93, same other stuff for healthcare projects. So mostly here in the country, we're working with these three documents: the approved document E, the HTM 081 for the healthcare sector, and BB93 for the schools. And if you look, let's just take the apartment, because perhaps all of us, we're not going in healthcare facilities or schools, but all of us, we're living in our home, and it might be an apartment. So if you look into the regulation in the approved document E, they say that walls, and so the acoustic performance between walls, between two apartments, or between two apartments for the, let's say through the floor, so the slab, should be 45 dB. But what? It's DNTW plus CTR. At that level, usually you lose some architect in the way, because they're not trained to speak the acoustic language. So again, an acoustician or the manufacturer can help you to understand what is DNTW and CTR. So quickly, DNTW will be a site performance to achieve, and CTR will be a low frequencies correction that we will need for some performance. So say 45 dB might become, in terms of laboratory value, you might want to achieve like something between 55, 57 dB to make sure that you achieve that site performance. This is the site performance you want. This is the actual performance that will bring you the well-being you need to live in this apartment. But then, what are we using in the country? If you knock your wall, you will see it's solid. It might be concrete, it might be blocks. And when you want to design with blocks, the mass of the block is the most important. So the more you have mass, the more you will get acoustic. A partition inside the apartment, about 10 centimeter, if it's 140 kg per square meter, you will get RW44. RW is not the NTW, RW is the laboratory value. So you will lose a little bit once the system is installed. But again, the mass is the most important when you design a wall with such building material. So what if you want to achieve, this 57? You have to increase the mass, and you have to increase the mass so much, because you need to double the mass every time you want to increase by +4 or +5 dB, which is huge. And it's easy to understand that the more mass you have on the walls, the more mass is going on the structure. So of course, in terms of structural engineering, then you have to adapt the amount of concrete, and you have to adapt the quantity of concrete as well, or columns and structural elements. If you look into the EPD, so the Environmental Product Declaration, there is some data available in UAE. I will show you the name of the website where you can find the EPD later. EPD verified by third party, very important. But in the country, you have one precast concrete EPD and two ready-mix concrete EPD. Unfortunately, there is no AAC or masonry block EPD at the moment. Should come, because every time you're working on a lead project, you need to provide this EPD. So for sure, these manufacturers, they will have to comply and develop their own product transparency documents. But let's look into it. The global warming impact, which is something we all should be looking when we select a material. Here, you will have 271 kilograms of CO2 per functional unit. So for the concrete, usually it's 1 square meter or 1 cubic meter or 1 ton of concrete. If you look the ready mix, you will be 215. So for the concrete, usually you are around 300 kg of CO2 per functional unit. It's a lot, but why it is a lot? Because if you want to create cement, the cement you need to cook it at, let's say, 1650 degrees, if I remember well, which is a lot of energy. You need huge facilities, you need a lot of energy, which is huge. So when you use that kind of material, better to use it well, because every kilogram of concrete or masonry block you're using has a huge impact on the environment. And this is only for the global warming impact. If you look at the energy, yes, energy 2.68 megajoule, and here 2.5, yeah, 2.5 almost, and the water, it's a lot of water to produce a little bit of concrete, because it's part of the process. Of course, there is alternative, so we will look into one alternative. But look at, okay, now imagine you're in your building, and the company who designed the building is respecting the regulation and did a huge brick wall or masonry wall between the two apartments to achieve this DNTW plus CTR 45 dB, the one we saw in the regulation. You need to bring the electricity in your home. So you have RW57. This is complying with the regulation. This is achieved thanks to the mass and to the thickness of the wall, so the overall side of the wall. Of course, you will have plaster, both sides, because you want the system to be airtight. You don't want the noise to travel through the air. But then what happens if you have to fix an electrical socket? You will not put it outside of the wall. No, nobody wants that in your home. So people, the MEP contractors, they will dig into the wall, and then you will have a hole in your wall. So what about the acoustic? Because we know that the acoustic for a masonry wall depends on the mass and depends on the thickness. So if you remove that part of the wall, then the acoustic is different. And this is what we call flanking in that case. You will have a sound transmission through that part. Why? It's just because this is the weakest point in the wall. So this, you will never see that in the regulation. It's not that detailed. That's why the acoustic consultant can help you with that. But you know what? In Dubai, actually in a lot of places in the world, because design is, there is a process, and for some project, you do a repetitive design for different rooms. You might have mirror design. So you might have one electrical socket on each side of the wall, and then the thickness is way less. So there is a huge impact. What about this acoustic there? And I don't know for you, but in my home, I can hear my neighbors. It's not supposed to be with this massive concrete wall. You're not supposed to hear your neighbors, because this is what is supposed to achieve your well-being. But if you hear your neighbors that something is going wrong, and it might be because of the flanking, and it might be because the where these electrical sockets are being located. So again, here we have an example where we use a whole technology, which is masonry block. This technology is using a lot of resources, a lot of raw materials, a lot of energy, but then it's not helping you to be comfortable in your home. So that's a big problem, because if you keep building with such system, then you will have to do some retrofit. Then you will have to improve the performance of the wall, because if, let's say, if the regulation changes tomorrow, and if Dubai municipality start to go in the home and to do some on-site tests and see that some buildings are not complying because the site performance is not achieved, then they will ask to do some retrofitting and to improve the acoustic performance. And then you will use new materials. So we don't want that. We don't want to use that much material in the first place. So we have to look to alternatives. One alternative is drywalls. The drywall doesn't work with this mass law. It's working with a concept named mass spring mass. So instead of a big amount of concrete, you want to do something we call decoupling. And you will have one mass on each side of what we call a spring. The spring can be a metallic stud. In some country, it's a wood stud. Like in the US, you can use a wood framing. And depending of the mass you have on both sides, and depending of whatever you have in the cavity, such as insulation, for example, glass full insulation, and depending of the size and the shape of that spring, you will improve the acoustic. The problem is, for this system, this is more complicated. Block wall is simple. People, they believe they understand block wall 100%, so they just put some blocks, done, finish. But drywall is more complicated. So for all the details we discussed, the penetration details, you will need to know the exact way how to build it. So you need a little bit more knowledge, or you need a little bit more support from the manufacturer. Also, even for the acousticians, this system can be a little bit challenging because there is so many components. You have to use a screw to fix the gypsum board on the stud. Depending on the shape and the thickness of the stud, the energy will travel in the different way. Then it will be fixed again on the other side. Depending of the insulation inside, the density, the thickness, a lot of parameters are affecting the acoustic. And you cannot use a simple mass law rule to know what will be the performance. So that's why any system, any drywall system should be tested. And the manufacturers are doing that. They're testing the system in a lab. There is great lab in Dubai, such as the Dubai Acoustic Research Laboratory in Jebel Ali. And then you have a massive room with full of concrete both sides, and then the hole in the middle. And then you build your system. And on one side, you have some speakers, you generate noise, 100, 105 dB. And on the other side, you have a mic, and then you will measure different frequencies. And then you will have your report with your performance. And that performance will be what the acoustic consultant will require. So again, it's a little bit more difficult, but you will see that the impact, the positive impact in terms of environment are there. If you compare the performance of a block and a performance of a drywall, you will see that it's exponential performance for the drywall, because you don't need to increase the mass. You don't need to double the mass each time you want to get 4 or 5 dB. That's why you will never see a concrete wall or a masonry wall in a cinema. It doesn't make any sense. It will be too expensive. It will be too heavy. It will be too damaging for the environment. So instead, you will have a drywall system for a cinema. And then same, even with a basic drywall system, you will be more efficient. So again, you have a different technology, and you have to learn how to use that technology so you can improve the acoustic performance and improve the well-being of people in the room. So let's just compare. We keep this RW 57 dB performance, which is the target we have between two apartments. And if you use a massive concrete wall, you will have a minimum of 180 millimeter of concrete, and then plaster on both sides. So usually we have 10, 15 millimeter of plaster. So at least it's like a 200 millimeter solid wall. In front of that, you can have a lightweight partition. Okay, you have 2 layers of board. You need a little bit of mass because you have to achieve that acoustic performance. You have a well-engineered metal stud shape, and then you have again mass on the other side. And in that cavity, you will put insulation. The total thickness of that system will be 12 centimeter, and you will achieve the same performance in terms of acoustic. But it will be 30% thinner. It will be 90% lighter. 90% lighter. So in the structure of your building, it means less concrete. It means you reduce the size of your column, of your structural beams. And of course, you reduce the amount of material you use to carry the building. So just by selecting the right system, you can save a lot in money, and you can also save a lot in material on the project. And also it's only 12 centimeter. So the same acoustic performance, you can achieve 12 centimeters. So you save space. So it means bigger room, or it means smaller buildings with the same space. So again, less material. Just by switching from one technology to another, then you can save a lot on many different aspects. And then I will take the same example than the block with the electrical socket, because you might say, okay, I will still need to fix to bring electricity in my building, even if I have a drywall system. So how do we do that? You will build the frame first. So you have a channel on the floor. You will have a channel on the slabs of it, and then you will have a stud. So it's an elevation that we're talking about. On one side, you will put the board. Maybe one board, two boards, three boards, depending of the acoustic performance you have to achieve. It might be a basic board, it might be an acoustic board, maybe a fire rated board, depending of the different parameter you want to achieve. And then you will bring your MEP, the cables, electrical cables, so you can have some cutout space in the studs where you can bring the cables. Then you will reach the space where you want to do the socket. You fix your electrical socket, and then you board, and then you just cut and you access to that part. So the hole will be exactly matching with the socket, and this will be properly sealed. And with that sealant, you will maintain the integrity of that face of the wall. And then you can keep using that concept of mass, spring, mass. It's not like you remove some material from the cavity, but because it's a cavity, there is nothing. So you don't remove material. So you don't damage the performance of the system like you will have with a solid wall. No, here it's well engineered to achieve the performance. It has to be sealed, to be properly sealed. So of course, in real life, it's not that simple like on the screen. So you need to propose proper detail. And when the architect, when the designers they're doing the details for the project, they have to propose such detail. The one I propose on your screen is actually the worst case scenario. It's when you have double back-to-back socket. But even with that, we have the details to maintain the acoustic performance of the system. It's not recommended. We always try to stagger the position of the sockets, not back to back, but like one on one side, the other one on the other side. But if we have to, and this is happening all the time in hospitals, if we have to, then we providing the right details. And these details, they have to be in the project information before the project is tendered. Then the manufacturer has to support, of course, the contractor by reviewing all the details, shop drawings, and to make sure that this is well done. And if it's possible, the manufacturer should also support the installation, train people to make sure that this is well installed. So see, it's a little bit, it's additional steps compared to the block systems, the block wall. However, you use way less material, and the acoustic is much better. We did this project in Abu Dhabi. It's the Fairmont Hotel at the end of the Corniche. So on this project, it was interesting to see that the client, he wanted to go with drywall, but not for the full project. So what happened is one tower is hotel, and the other tower is hotel apartment. And the client for the hotel apartment, I believe he saw that perhaps some clients that will damage the walls, or I don't know. So he just say, okay, let's do it with blocks. So for us, it was a good opportunity to compare, because it was exactly the same specs on both sides. So if you compare the installation, it's 20 weeks to install the block and only 7 weeks to install the drywall. So you save time. Means you don't have to allocate material and resources on site for the workers. You can reduce the time, and you can open the building earlier because you save weeks. So then it's impacting the ROI. The weight, if you compare the weight of the block and the drywall, it was actually 65% lighter as an average on that project. 65%. Imagine if you can reduce by 65% the dead load on your structure. Even if it's a G+4 or G+5, you can save a little bit. So imagine on the G+10 or on this project, which is G+35, I think it's huge. And then in terms of transportation, you remember that a block wall, you need mass. You need to carry actually the mass of the system if you want to get that performance. But with drywall, it's empty. You need that cavity. It's also part of the performance of the system. So it's 75% less deliveries, which means, yes, less trucks, less energy to transport the material. And of course, also less forklift use on site, which makes your site safer. So here we're talking about the well-being of the end user, but think about the well-being of the installer. He doesn't want to carry the blocks. No, here, yeah, with a drywall system, it's also well-being for the installer. So let's come back on the EPD. Again, I will show you where to find those EPD, because every environmental product declaration is a third party, should be a third party verified document, and it's transparent, so you want to publish it. So there is a public library. I will show you in a few slides. So let's take a typical gypsum board that we have for between two apartments, or between two hotel rooms, or two patient room in hospitals. This one from GPROC, the GPROC sunblock board. It's an acoustic gypsum board. So it's not the basic board. I took voluntarily, I selected a board that is emitting more CO2. So because this might be the board used between two units. But I don't know if you remember the amount of CO2 for the concrete, but even it was one cubic meter, and here it's 1 square meter. But even if you scale it as per the requirement on the project, here it's only 3 kilograms, 3.4 kilograms of CO2. The savings are huge. The global warming impact saving is huge. The water consumption, it's almost nothing. Water consumption is nothing. You don't use water. It's a dry system. That's why we call it drywall. And the energy consumption, 77 megajoule. It's like you need to cook the board at like 165 degrees, which is almost what you need at home to cook a cake. So just by selecting the right technology, providing the right details, you can save a lot on the building. So this is the material, and then you saw that this system is the system using the gypsum board is way lighter, so you save on the structure as well. When you have enough data on your market, when you have this EPD published on your market, you can compare systems, the full systems. And this is something we've done in different countries. But again, as I said, we don't have enough data on the block manufacturer in UAE. They're not disclosing enough information for us to compare a drywall system with a masonry wall. But we've done it in several countries. We've done it in South Africa, we've done it in South America, in the US, and also in Vietnam. And I like the one in Vietnam because the market is quite a lot of similarities with the EU market for drywall. So let's take a drywall partition, 1 stud, and 2 layers of board each side, and the insulation in the middle. And in front of that, you put a 200 millimeter brick wall with plaster on both sides. When you compare the two LCAs, you are able to compare with the same functional unit, might be 1 square meter or might be 1 cubic meter, but you compare anyway. You compare the performance. And then the global warming impact, you can see it's 6 times less for the drywall. Again, matching the same performance. If it's fire, acoustic, air impact, whatever you want, we're matching the same performance, but with a lower global warming impact. Then the amount of energy will be way less. The amount of water, it's almost nothing. Really, it's 10%. It's nothing. And if you look the load, same. You can save up to 90% of the load of the system. So of course, the system in terms of acoustic will be better. It will help you to achieve a better well-being for people while performing and achieving what the regulation is asking, of course. But the additional benefit in terms of sustainability are huge. And you can save so much. You can reduce the embodied carbon so much just because you're selecting the right material and you're moving forward the right design. Yeah, so these are the same figures: 85% reduction in global warming impact, 74% reduction in primary energy, 88% for the weight of the wall, and 86% for the reduction of the water. So great reduction, right? So if you build, let's say, a 40 floors, 40 stories building, you might achieve this 10,000 square meter of drywall. 10,000 square meter of drywall compared to the brick wall, it will be like 68 trips around the planet by car. It's the amount of CO2 you're saving. That's huge. And the load, it's like, okay, they're in Vietnam, so they love elephant. I might try to do the same with camels for the next presentation, but here we have elephants, so it's 75 elephant in terms of tons. It's 2,700 tons saved on the load of the building, and 3 million liters of fresh water. And you know how important is fresh water and how it will be critical to save the fresh water in the future. So if you know this information, and if you select the cement-based technology to do a wall which is not load-bearing, so we don't need this compressive strength of the concrete. If you do that choice to go with a cement-based product, you make that choice that you will use this amount of water. So that's why we're doing product transparency. It's to increase the awareness, and we want to demonstrate what is consumed, so you can take the solution. So, and this was an example for internal partition, but keep in mind that this is a concept. Lightweight construction, it's the concept. So you can actually replicate that concept in a lot of different situations in the building. So internal walls, easy, done, discussed. Shaft wall, you can do the same system, no problem. What about the external wall? The wall between your home and your balcony. This can be done as well. Can be done with another gypsum board, so you don't have to use cement product. And this will achieve a better acoustic, in a lightweight way, and you will reduce space because you can save space as well. I have to say that most of the product I've been talking about in the gypsum family, even the metal and the insulation, they are produced locally. So the board, for instance, they're produced in Abu Dhabi. So you don't have to travel to bring back the product from Europe or from US. It's not a new technology that it's only available on the other side of the world. No, it's available locally for 20 years. So you can select that system because it's available locally, and there is great companies able to install it. You just have to consider the lightweight solution during the design. Even if you want to do the same but with high energy efficiency, so it's not the purpose of that presentation, but if in addition of acoustic, fire, you want to have great thermal performances and reduce the energy consumption of the building, you can do that. You can use that full system with a lightweight substrate and AIFs or ATIC system on top of it. And with 20 centimeter, you will just overperform any blocks, and you will achieve a great performance and a great durability. So you will reduce the energy consumption of your building, and of course the impact of the global warming impact for this energy consumption, because it's always better to not use energy. In the same mindset with lightweight systems, there is also another system that I love. It's actually the pre-insulated duct. You know, these GA ducts that you have in most of the building. You have to design, you have to build them in the factory. Then this is delivered on the back of the truck, and if something happened, then it might be damaged. So hop to the trash, and then you have to order a new one. It might be damaged during the installation. It's heavy, so you have to fix them to the structure. There is alternative, and there is what we call the pre-insulated duct, Climaver pre-insulated duct, and it's coming as a board, and you just cut the board depending of the shape you want to achieve, and that's it. And this is lightweight. You can have an acoustic mat included inside, so you can reduce the acoustic noise of the equipment, of the HVAC equipment. That it's like embodied into that foil, so this aluminum foil. So there is no fibers. It's very safe. It's very light, and again, you use less energy because the glass wool you will use inside, the amount of recycling content for glass wool, it's close to 100%. So the bottle you drink, the glass bottle you drink in the restaurant, in your home, it will be recycled, and then it will be recycled perhaps in that material. So it's great. So see, you might even walk in next time you're going to IKEA, next time you're going to the mall, look up and try to see if the system installed is lightweight and is adding weight on the structure, or if it's lightweight, and then you just fix with simple fixture element, and then you just save installation comfort, acoustic comfort, and then you don't add load on the building. So look up next time you're in a mall, or next time you are in just look up, just look at AV can be that systems, and you have lightweight alternatives cheaper. So again, this is part of the design process. We need to spread awareness that lightweight technology are better, environmentally speaking. They will be better than the heavy systems, and they're not more expensive. So all the designers, they should be aware about that. The last part of that presentation is focused on product transparency. So I already done one technical workshop with the GBC about the EPD, and for 1 hour it was about EPD, how to use an EPD. So I will not do that again. I think you can find the data on the GBC website. However, it's good to give you a small reminder why we're doing EPDs and on what is based the EPD. So the EPD, the Environmental Product Declaration, is based on what we call a life cycle assessment, or LCA, and you will take the whole life cycle of the product. We set cradle to grave, and so from the raw material extraction to the end life of the product. And for all of this stage, A, B, C, D, etc., we will monitor the global warming impact, the consumption of raw material, of energy, VOC, a lot of topics. And in the EPD, you have all of that information. So if you select one material, if it's a building material, but in some countries, there are EPD for everything, for a paper cup, for plastic bottle, for IKEA pot, for the plants. I'm just looking around myself, and I try to look what we could have for EPD. And then by looking at 2 EPD, you can select the product with the less impact. So this document, they have to be third-party verified. So we're sure that the information is correct, verified. There is no mistake in the calculation, because that's this EN 15804. It's quite difficult. So you need LCA engineers to do that, and you need a third-party verifier. And this is the website. If you have to take one picture today on your screen, or one screenshot, that's the one. That I would say that's the most important website you have to use if you design a building, because you will be selecting the material, you want to see what is the impact of the material on the project. So on EnvironDeck, you can search the database. It's worldwide. It's if the EPD is third-party verified, then it will go on. You can publish on the EnvironDeck, and you can look by country, by sector, by type of material, and then you can see what manufacturer did the effort of transparency, disclosing information on the product. And then when you have two products from the same family, you can just compare the impact. And just this exercise will do a huge difference for the building emission. At Saint-Gobain, we have, I think, worldwide more than 900 verified EPD. I think it's closer than 1,000 now. And here locally in UAE, I think we are somewhere between 30 and 40 EPDs. You might have some document for insulation, for gypsum products, for mortars, even for glass and acoustic ceilings. That's something we can provide. So we're here to support you. We have a big team of specification managers able to not talk about just to sell product, but to discuss the concept of acoustic, but also fire sustainability on the project, and to give you choices so you can select the right material as per the performance you're trying to achieve. Thank you, everyone. If you have any question, just use the chat. I think Jinan will take it from there. I just have one additional slide. I know that Rumble is part of the GBC, and the next slide is actually an article published on LinkedIn by Arut, who's an acoustician in Rumble, and who is explaining very well, that the difference of performance you have in the regulation and what is actually achieved on site. So that's actually a good article to understand quickly the issue with acoustic on the project in Dubai, because that's very related to Dubai. Thank you.
Thank you very much, Dorian. I don't know about all the other attendees, but I personally found your presentation very interesting, especially when you mentioned the part that you can hear your neighbors in your apartment, because I have the same problem. When my neighbors turns on the tap, I can hear that they've turned on the tap. So yeah, I think this is a problem that we all suffer from here in this region.
Yeah, exactly.
Okay, everyone. Yeah. So today we have a small group of people. So if you have any question, you can utilize the hand raising feature that you'll see on your toolbar, and I'll see if I can unmute you so you can ask your question in an audio. Just waiting to see if anyone will raise their hand.
Whilst we're waiting for some additional questions to come in, Dorian, I had a question for you with regards to the drywall system. How does drywall installation hold up in terms of the fire safety issue? As in, how well does it do against fire?
So actually, I would say almost 100% of the drywall system, especially in the Middle East, are tested for the fire without insulation. So the gypsum board itself will provide the fire protection and fire insulation as a system. The insulation we're putting in the cavity is mostly used to improve the acoustic performance. Only in few specific systems you might need some stone wool at the end of the partition if you have a deflection head detail, or it might be on top of some framing, for instance, in a fire-rated ceiling system. But otherwise, most of the drywall system you can find around you, the insulation is used for acoustic purpose. So the system is certified by civil defense without the insulation.
So it's really interesting to see that like the drywall system, like not only like you use less weight, it has less impact on the structural elements. It provides good acoustic properties. It has good fire safety uh, grades as well. But like apart from the reasoning, like okay, it's a bit more complicated to sort of model it on from acoustic perspective. Like what else do you think? Like why else do you think like drywall isn't as popular or isn't used as often here in the region, or I would say in the UAE to be more specific?
I think after working 4 years in that country, I think the main problem is that first of all, it's not taught in the universities. I think it's a big problem. So there is no awareness and there is no discussion. I mean, nobody is degreed as the degree from architecture and with full training or full module on drywall. And you see that it's an important technology that has huge impact if you select them. So it should be part of the education program for architects and designers. The other aspect is that the drywall technology is 100 years old. It's not new, and the manufacturers they needed time, to develop the right type of board and the right type of system for each situation. And everybody, if you close your eyes, you think about an Hollywood movie, and all the time there is people escaping through a wall, a drywall, but it's because this is a mindset from before, where you just had like a weak gypsum board. But with time, we developed a different type of gypsum board, and you can have 2 layers of gypsum board. And I think in the region, people are a little bit concerned about the durability. So what we're doing, we're explaining the standards. We are demonstrating that with third-party testing, the impact resistance is actually the same performance for a masonry block than a drywall for some system. And then we're also doing some seminar where we are welcoming clients. We're building a different type of partition. We're telling them, look, this is the internal partition you can have in an office. This one is the one you can have in your home, in between your bedroom and your living room. And this one is one between your 2 apartments. And we ask them to destroy the partition, so they can see by themselves that it's very strong. And that's just about perception. And the last point, I would say it's moisture resistant. And for the same reason, some people believe that the gypsum is not adapted for water. So, okay, if you have water in the gypsum, you might lose some strength performance. But what we created since a long time now, it's different grade of moisture resistant gypsum boards that are not absorbing water, or a very few amount of water. So in that case, the board is not damaged by the moisture, and then you will keep it for the life of the building for 70, 75 years. And this technology is so good that you saw in the slide, we're using the gypsum board externally in Dubai. So that's what we can do. But again, it's about mindset, it's about perception, and I think education and awareness. That's the main problem for me, is education and awareness.
No, I 100% agree with you, and I think you would be happy to hear this as well. So we were in discussion with one of the projects here in the UAE. I think you might know them, but I'm not going to mention it by name. But they're looking to basically reduce the embodied carbon, and they're going for one of our certifications that we offer, the ILFI zero carbon certification. So we were in discussion with them, and they were looking at like different structural options as to how they can reduce the amount of concrete they're putting in. And sure enough, like the conclusion they came to was like, okay, we use lightweight facades, and lightweight facades meaning gypsum board drywall systems, and really it almost reduced the embodied carbon by like almost half, which is not surprising. And given seeing it from the EPD data as well, it's very clear like the impact that you can have just by sort of rethinking and redesigning your structural elements in your project can have a huge impact on your embodied carbon.
Exactly, and I think it makes sense in terms of design. It's just logical to use the most strongest material, which is the concrete, as a load-bearing material. And if you don't need part of the system to be load-bearing, just get rid of the cement. Just save on the material, because alternatives on the market are just doing better. So again, awareness, and people, they have to spend, the companies, the company you mentioned, that took the time to study, to understand by themselves. So I think moving forward, they will have great opportunities for their future, because they will be able to design faster, they will be able to build faster, and they will have less maintenance cost on the project. And because they did that exercise to compare, it's taking time, but then there is huge benefit. So yeah, I invite every people here during that webinar to do that exercise. Even if it's not drywall, comparing drywall and masonry wall, in your own industry, you take decision and you select material for diverse reasons. So do this exercise. Look if the alternative is available on the market. Look if you have EPDs available, and do that exercise to compare the performance and the environmental impact of the product.
And just to add to that as well, you would notice, so like the point of doing life cycle analysis or carbon cycle analysis of your projects is very important. And usually the barrier was that it's quite expensive and complicated to use these tools available. But now, quite recently, we've partnered with BioNova, who is the developer of the one-click LCA, and they're offering a completely free tool which is called One-Click Planetary. So it's through our partnership that we are able to offer this tool free of cost for all companies in the UAE. All you have to do is just go ahead, register, and what it does is basically it has 10 most used materials for building for projects that you can select up to, and you can actually in your design you can basically specify the amount of material that you're using. For example, you're using a ton of concrete or whatever, and then you can actually side by side compare it to, let's say, project B, where you use maybe half the amount of concrete, or you maybe use a concrete with recycled content, or you don't even use concrete, and you can compare the carbon, the embodied carbon within for that project. And we did a webinar with them as well. I think it was previous month. With BioNova. So I encourage everyone to have a look and just use that tool. It's available freely. And I think it's really, really important, as Dorian mentioned, just to raise your awareness, to do the sort of analysis yourself and see the stock differences you can get from just choosing the correct material for the right purpose.
Yeah, and Jason, I would like to add to that that we have to get out of that mindset that in order to reduce our carbon footprint, that it's just about the fixtures, whether it's light fixtures or water fixtures in the build, that we should look at the build itself first. I feel that that type of thinking is still not very developed in the UAE.
Yeah, exactly. That's something we see with my team every day. But that's why we're doing produce transparency, by being transparent and by you can spread awareness. But yes, there is a lot of education to do, and hopefully thanks to GBC and new impact you have on the awareness, it might get better.
Yeah, I agree. Maybe we should hold other workshops on such topics. See who else is offering this technology. See who else is trying to spread the awareness, so we can hopefully reinforce this position in the region and make it more popular.
I agree. It would be great.
Okay. Yeah. Okay. To conclude, I would like to thank everyone here once again for attending. I found it very interesting, and I hope that you found it interesting as well. At the end of it, you will receive an email from our side that has the presentation, and it also has the recording of this presentation, so you can go over it in your free time. And I would also like to remind everyone here that the window to apply for our MENA Green Building Awards is open. So please check our website, see what categories we're offering this year, and apply. And hopefully you will be one of our winners for this year. Thank you very much once again, and hope you have a good rest of your day.
Thank you, Jinan.
Thank you, Dorian.
Bye, everyone.
Bye.